Hey everyone, welcome back to another lesson in Math 2. Today we're going to be talking about converting standard form to vertex form. We've already talked about the other way, taking the vertex form of a parabola and converting it to standard form. How do we go backwards? Well, fortunately, the last lesson that we did helped us understand how to find the vertex from standard form. And so we're just going to utilize that in order to rewrite the equation in vertex form. So with that said, our goal today is to be able to rewrite quadratics in different forms. So since we already know one way, we're going to add to that going backwards basically, okay? So first off, we should probably practice a few problems before we move into the actual concept that we're working on to make sure that you have a good feel for what it should look like, okay? So it says determine the vertex of each of the following. So we want to find the vertex in number 1. Well, that should be pretty easy. The vertex for number 1, that's already in vertex form. So we can just pull the vertex out of that without any problems at all. Remember, the vertex is the h value and the k value. The only thing we have to do is change the sign of the x value. So the vertex in this case is going to be -7, -3. Change that sign, keep that sign. So nothing new. We've been doing that for a while now. For number 2, we have h of x equals 3x squared minus 18x plus 29. And so this is standard form. And since I'm asking for the vertex here, I've got to go through the motions that we did in the last lesson. How do we find the vertex? Well, the first thing we have to do is find our axis of symmetry. And remember, our axis of symmetry, the equation for that is x equals -b over 2a. And so we have to identify our a value. So our a is 3. Our b value is the number in front of the x, so our b is -18. And then our c value is +29. It's the constant at the end. And so all we have to do is plug that into our axis of symmetry equation. And so we end up with negative, because that says negative, b is -18, so -18 over 2 times 3. And then that will simplify to, well, negative is +18, and 2 times 3 is 6. So our axis of symmetry is going to be 3. Okay, that's the first thing we have to do to find our axis, or to find our vertex. The next thing is we've got to take that x value and plug it back into the function to figure out the y value. Don't get caught up, don't get worried about h of x. All that means is y, okay? So we're going to plug in 3 for x, because that's what we got for our axis of symmetry. So that's going to say 3 times 3 squared minus 18 times 3 plus 29. All right, let me zoom out a little bit so we can see that all together. So all I did was plug in the 3 into each of the x values in our function so that we can find our max or our minimum value. So h of 3, remember order of operations, we want to do those exponents first, so that'll be 3 times 9, 3 squared is 9, and then carry down everything else. And then from there, we'll go ahead and multiply. So 3 times 9 is 27. And 18 times 3 is going to be 54. And then plus 29. 36, 46, 54. Yeah, that's right. Okay. And then 29 plus 29 is 58, minus 54 is going to be 4. So h of 3 is 4. So that tells me that my vertex, remember, is made up of my axis of symmetry and my max or my minimum value. So my vertex would be 3, 4. And that is my answer for number 2. For number 3, I'm not going to really do this one, okay? This one is going to require a lot more work. We're going to have to convert number 3 into standard form, and then we're going to have to use that and find our axis of symmetry from our standard form, and then do the same thing we did in number 2. So I'm going to skip over that one. If you want to try that on your own, the first step would be to multiply all this out so it's in standard form, and then basically do what you did on number 2. But with that said, let's go ahead and talk about how to actually convert from standard form to vertex form. So for our case here, I'm going to kind of go through it on the lesson, and then I'll do some practice problems on my scratch paper here. So vertex form, remember, is a times x minus h squared plus k. All we need to do is to figure out the vertex. If we can find the vertex, if we can find the values that go into those variables, those a, h, and k values, then we can write any function in vertex form. So here's an example of that. It says let h of x equal negative 2x squared plus 8x minus 5. Well, we've got to find our vertex. So remember, to find the vertex or our axis of symmetry, we're going to plug in x equals negative b over 2a. So identifying our a value is negative 2, our b value is 8, and our c value is negative 5. So we plug that into negative b over 2a. So we have negative 8 over 2 times negative 2. That simplifies to negative 8 over negative 4, which is 2. So now I have my axis of symmetry. And then I plug that in to find the y value to get my vertex. So remember, do our exponents first. So 2 squared is 4. And then we'll do our multiplication. Negative 2 times 4 is negative 8. 8 times 2 is 16. And then minus 5. So negative 8 plus 16 minus 5 is 3. And our vertex then would be 2, 3. Okay, that's just another example of what we just did. But now we need to identify our a, our h, and our k values. Well, remember, the a value in vertex form is the same as the a value in our standard form. So in this case, our a value is just negative 2. Our h is the x value of the vertex. Our h is this guy, so our h is 2. And our k is 3. It's the y value. And so all we have to do is plug that in to our vertex form. We're just going to substitute into that. So we would end up with y equals negative 2. Negative 2 goes in place of a. Notice I color-coded it. And then the h value is the purple one. So we plug in our h value there. Notice that says x minus 2 squared and then plus the 3. We can simplify that a little bit by getting rid of that negative, or that 2, the parentheses in the 2 and the parentheses around the 3. The bottom line is this. The a value is negative 2, it's the same thing. And then our h and our k values, remember we just take the sign of the vertex. That's 2, so we make that minus 2. And then we keep the sign of the y value. Change the sign, keep the sign, just like we always have. And so we have written vertex form from standard form. Pretty straightforward, pretty easy, I think. So let's go ahead and take a look at some practice problems. You should be doing these on your own. And then after you think you have it, compare what you did to what I did to see if you're right. For number 4, we have y equals negative 4 x squared minus 12x plus 1. Well, let's go ahead and find our axis of symmetry first. Axis of symmetry is x equals negative b over 2a. So our a value is negative 4, our b value is negative 12, and our c value is 1. So our axis of symmetry is going to be negative 12 over 2 times negative 4. And then that can simplify to positive 12 over negative 8. And this is going to be a little bit gross because this is a fraction. So this is going to simplify to negative 3 over 2. And then that's our axis of symmetry. Axis of symmetry is negative 3 over 2. Or you could say it's negative 1.5, 1.5 if you want. But then I need to plug that into my function. So it'll say y equals negative 4 times negative 3 over 2 squared minus 12 times negative 3 over 2, and then plus 1. Let's go ahead and simplify that. So we're going to do our exponents first. So we're going to square the negative 3 over 2. Negative 3 over 2 times negative 3 over 2 is going to be 9 over 4. So it's 9 over 4. And then we'll carry everything else down. So it's negative 3 over 2 there, plus 1. Then we do our multiplication. Well, when I go to multiply these fractions, how do I multiply fractions? I put this over 1 and multiply straight across. So I'd end up with negative 36 over 4. And then here, put that over 1. Negative 12 times negative 3 is positive 36. And then 1 times 2 is 2. And then I can actually simplify those nicely. Negative 36 over 4 is negative 9. And then 36 over 2 is 18. And then add the 1. And so that simplifies. Negative 9 plus 18 is 9. Plus 1 is 10. So now we know that our vertex is going to be negative 3 halves, comma 10. Then from there, to plug into our vertex form, well, remember, the vertex form is y equals a times x minus h squared plus k. Well, what is our a value here? Our a value is the a value from our standard form. So we would say that a is negative 4, h is the x value in our vertex, so that's going to be negative 3 halves, and then k is our y value, so that's 10. And so when I go to plug it in, I get y equals negative 4 for a times x. Because that says a minus sign, I'm just going to change that sign there just like I always do. So it'll say x plus 3 halves squared. And then since that says a plus, I'm going to keep that sign. So that'll say plus 10. Change the h value, keep the k value. So that'll say plus 3 halves. And then that's positive 10 because that's already positive 10. And that is our vertex form. Okay? So pretty straightforward. I know that was a little bit more complicated because I know there's fractions involved there, but it still is pretty simple, I think, overall. All right, the next problem is in factored form. We're going to go ahead and walk through this one to make sure that we understand it in its entirety, though. So we're going to go through this by putting in standard form first. So remember, we need to multiply this out. So we're going to say x times x plus 11 minus 3 times x plus 11. We'll go ahead and simplify that by distribution. So that's x squared plus 11x minus 3x minus 33. And then combine like terms, so we get x squared plus 8x minus 33. And then we still have that 5 out front, so we're going to put parentheses around this and put a 5 out front, and we'll distribute that 5 in. So that'll be y equals 5x squared plus 40x minus, let's see, that's 165. That's a big number there, all right? Okay, now we can find our vertex pretty easily. Finding the axis of symmetry, we get x equals negative b over 2a. So that would be x equals negative, what's b? B is 40. B is 40, so negative parentheses 40 over 2 times a. A is 5, so 2 times 5. And then that would simplify to negative 40 over 10, which is negative 4. So I have x equals negative 4 for my axis of symmetry. Then I'm going to take that and plug it into my y, or into my x value of my function. So I end up with y equals 5 times negative 4 squared plus 40 times negative 4 minus 165. And then we'll simplify that doing the exponents first. So that's going to be 5 times negative 4 squared is 16. And then we'll carry everything else down. And then we end up with, well, 5 times 16 is 80. 40 times negative 4 is negative 160, and then minus 165. Simplifying that, this is going to be a pretty big number here. 80 minus 160 is negative 80. Minus 165 is negative 245. And I want to verify that. So where is my calculator? There it is. I'm going to verify all of that is correct. Let's see, 5 times, oops, I typed it in wrong too. 5 times 16. You know, basic arithmetic sometimes throws us off. All right, so we have our y value of negative 245. That would mean that our vertex is going to be negative 4, comma, negative 245. And now I have enough to figure out my vertex form. So y equals a times x minus h squared plus k. Well, my a value is the same a value as I had originally, which is 5. So that'll say y equals 5 times x. Then we have minus h here. So we're going to take the h value of our vertex here. Here's our vertex right here, negative 4. We're going to change that, so that's going to say plus 4 and then squared. And that says plus case, so we're just going to carry down the second part of the vertex. So minus 245. And that is our vertex form for number 5. All right. That we have one more problem to do that kind of just puts everything together that we've talked about with graphing parabolas. So let's see what we can do with this problem here. It says, let y equal negative 3x times x minus 6. All right. And in part A, it says convert that to standard form. So this one's pretty straightforward. It's not in vertex form. It's actually in factored form. All we have to do is distribute that. So we would say y equals negative 3x squared plus 18x. And that's in standard form. That's pretty straightforward. Then in part B, it says convert that to vertex form. So we'll find our axis of symmetry. That'd be x equals negative b. So negative, what's b? B is the number in front of the x. So negative 18 over 2 times negative 3. That simplifies to negative 18 over negative 6, which is 3. Our axis of symmetry is x equals 3. Then we want to plug that into our equation. So we get y equals negative 3 times 3 squared plus 18 times 3. And so that becomes, let's see, negative 3 squared is 9. And then we'll carry everything else down. Negative 3 times 9 is negative 27. 18 times 3 is 54. 18 times 3 is 54. And then we'll put those together. Negative 27 plus 54 is 27. So then our vertex is going to be 3, 27. So our vertex form would be y equals, what's our a value? Our a value was negative 3. So y equals negative 3 times x minus 3 squared plus 27. And so that is our vertex form for part B. All right, for part C, it says describe the transformation. So we describe the transformation based on vertex form. So let's just use this guy to describe it. We would say the parent function, which is y equals x squared, is reflected about the x-axis, and that's true because we have a negative a value. Then we would say vertically stretched by a factor of 3, because our a value has a 3. It's a stretch because that's greater than 1. And then we would say translated 3 units right, because our vertex was 3, 27, and 27 units up. All right, so there is that. Then it says to graph this thing. Now, graphing this thing in part D, looking at my vertex of 3, 27, that's pretty crazy. That's a lot of boxes. So I'm going to go ahead and rewrite my vertex form here. I've got y equals negative 3 times x minus 3 squared plus 27. And so when I go to graph this, I want to make sure that I have enough boxes, and I'm going to be graphing forever, it seems like, where I have 27 here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. All right. So I have my axis, or my x-axis all set up here so that I have it in the right place. All right. So from here, counting up, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, and then over 3. So there's my vertex, 3, 27. And then from there, we got to follow our slope pattern. Since this opens down, we know it's going to be down here. Our slope pattern, remember, is normally 1 over 1, 4 over 2, 9 over 3, and so on. But we need to multiply that by -3 because our a value is -3. So we end up with -3 over 1, -12 over 2, and -27 over 3. And that should be enough to identify our graph. So we're going to go down 3 over 1, and then down 12, so 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 over 2. And then because I got to go down 27, and I know the vertex at a height of 27, 27 is right on the x-axis here, and then over 3. So there are my 3 points here. Let me zoom out so we can maybe, or 4 points, see them all together. Okay, and then we're going to reflect that over the axis of symmetry. So 1 point away, 2 points away, 3 points away, and then we do our best at drawing a parabola. Okay, so there's that. So there we have our parabola for part D. For part E, it's asking for my X and Y intercepts. My X-intercepts and my Y-intercepts. Well, looking at this graph, remember the X-intercepts are when the parabola crosses the X-axis. We can see that here and here. Those are my X-intercepts. So we would say those coordinates are 0, 0, that one's 0, 0, and then the other one is 6, 0, 6, 0, okay? And then our Y-intercept is where the graph crosses the Y-axis, and you can see that it crosses the Y-axis, in this case, in the same place it crosses the X-axis, and that Y-intercept would be 0, 0 again, okay? For the domain, for part F, it says what's the domain in the range? The domain is the set of x values, and because this parabola keeps going to the left and keeps going to the right, the domain is going to be -infinity, less than x, less than infinity. And then the range, remember, is the highest point, or sorry, the lowest points and the highest points. Since this parabola keeps moving downward, we would say that the lowest point is -infinity, less than y, less than. And then what's the highest point? Well, the highest point is the vertex up here, and that was 27. So we would say that the range is from -infinity to 27 there, okay? And then for G, it's asking for the intervals of increase and decrease. So the interval of increase is where the graph is going uphill. Well, where do we see the graph going uphill? It would be beneficial for us to draw our axis of symmetry, so we cut the parabola into 2 pieces, the part that's going uphill and the part that's going downhill. So the part that's going uphill, the increasing part, is the left-hand side. So that would be from -infinity all the way over to this dotted line, all the way over to 3. So we would say our interval of increase is from -infinity to 3. And then our interval of decrease would be from the axis of symmetry, which is 3, all the way towards infinity. So 3 less than or equal to x, less than infinity. So that's our interval of decrease there. All right, and the last problem, this says find the average slope over the interval 1 to 4. What does that mean? That means our x, our first x is 1, and our second x is 4, right? Our first x is 1 and our second x is 4. So we've got to find our coordinates. Well, the first coordinate is 1, comma something, and our second coordinate is 4, comma something. We have to figure those out based on the graph. So if I go over 1, what is the y value there? Well, the y value when I go over 1 is this y value. That is 2, 4, 6, 8, 10, 12, 14, 15, it looks like. Count that again. 2, 4, 6, 8, 10, 12, 14, 15. And so our coordinate is 1, comma 15. And then our other coordinate is when x equals 4, So we're going to go over 4, 1, 2, 3, 4, and then we got to find that point. Well, when I go over 4, that's way up here, right here. Well, I can count all that. But that's 27, so I'm going to back away 3. So that is actually 24 high. I can count that up. But the coordinate is 4, 24. And then from there, all I have to do is find the slope between them. I could count the slope. I could say, okay, the rise is 1, 2, 3, 4, 5, 6, 7, 8, 9, and over 1, 2, 3. So then my slope is going to be 9 over 3, which is 3. Or I can use the coordinates and plug them into my slope formula. Remember, my slope formula is y2 minus y1 over x2 minus x1. And so that would end up being y2 is 24 minus y1 is 15 over x2 is 4 minus x1 is 1. 24 minus 15 is 9. 4 minus 1 is 3. So 9 over 3 is 3. So my average slope is 3 for part H. All right, that wraps up the lesson for today. The main purpose of this lesson was to be able to convert standard form into vertex form. And so the bottom line is, if you can find the vertex, using x equals negative b over 2a, and then plug that in to find the y value, then you can use those values to plug into the vertex form and you have it. This was a great review problem because we're going to keep seeing these types of problems throughout the rest of the year. If you have any questions, please comment below. Otherwise, catch me in a tutoring session sometime and I can help you out. I will talk to you all later.